All right, so this video I hope has a very bold title to it. There's something very simple that we need to talk about, but for whatever reason, this is something that is the, source of a lot of confusion when people take Calculus 2. Okay? Now, we've learned about sequences, and we've learned about series. And think about this as much as you have to for it to sink in. A sequence is not the same thing as a series. They look similar, they're sometimes involved in the same kinds of problems, but they're different, all right? So I wanted to make a video just to focus on that, just so hopefully we can all avoid confusion about it later. This is a series. A series involves repeatedly adding some numbers together, okay? All right, that's a series. This particular series I've used in a lot of my examples converges to 1. And what that means is that although the series goes forever, every time I add another number, my grand total is closer to 1. I'll never get 1, but by adding and adding and adding and adding, my grand total is going to get as close to 1 as you could ever imagine. All right? That's a series. This is a sequence. Notice that this sequence has exactly the same numbers as that series. Okay? But it's a sequence. It's not a series. What's the difference? A series involves the adding. Every time I add that next number, my grand total is closer to 1. A sequence, well, what's a sequence? Is there any adding? No. A sequence is nothing but an ordered list of numbers. That's it. Okay? It's a number, comma, and another number, comma, and another number, comma, and then it might go forever. They both go forever, but they're not the same thing. Even though the numbers are the same, they're totally different concepts. Now this sequence, we'll say, converges to 0. Why does it converge to 0? Because every number on this list is closer to 0 than all the ones that came before it. The further down this list you go, the closer the number will be to 0. All right? So both a series and a sequence can converge to something. But the meaning there is different. All right? So I thought, let's just look at some examples. Let's just see it that way. If you can tell the difference between these two examples, if you know what I mean here when I say it converges to 1, and if you know what I mean here when I say it converges to 0, then as long as you can keep that in mind, I think you'll be in good shape, okay? But it's something that you have to learn and you have to get used to. Series, sequence, they're different, all right? Okay. Now, a few other things, here's something that's related, but we should probably also talk about. Infinite series is not the same thing as the sequence of partial sums, all right? Because once again, a series and a sequence is different. So, here, for example, is an infinite series. It's geometric. The common ratio is a third. It converges to a half. I can add the numbers in this series. Every time I add the next one, my grand total is a little closer to 0.5, okay? But you may hear it talked about that you could take the sequence of partial sums, meaning if I had the first 2 terms of this series, I'll get 0.4 repeating. If I had the first 3 terms, I'll get 0.48. If I had the first 4 terms, I'll get 0.49. It does appear like the more terms I add, the closer my grand total gets to 0.5. But, it might be that we just list the sequence of partial sums, okay? All right, it's all related to the same problem, but it's different aspects of it, okay? By mentioning the sequence of partial sums, I'm just trying to give you a concrete way to think about what I said from the beginning. What did I say from the beginning? I said, well, the more terms of this you add, the closer your grand total is going to be to 0.5. So it shouldn't be too much of a surprise that if I had the first 7 terms, I'm at 0.49. I said the more terms you add, the closer the grand total is going to be to 0.5. Okay. So yes, there are distinctions, there are vocabulary, there are similar things you can get confused about. I'll put one more thing down for vocabulary. A series is the operation of repeatedly adding numbers, just like I showed you on the previous slide. A sequence is an ordered list of numbers. See this? There's no adding. That's just a list of numbers. Okay? All right. So, and I like to put things in writing, but with this sequence of partial sums and that series, I mean, all it does when I write the partial sums is indicate that the more terms I add, the closer we'll get to a grand total of 0.5, right? You can see it. You can see it. Okay? Nonetheless, however you think about it, you're going to keep these things separate. Series, there's an example if you want to think about it. If you want something to associate with that word. Sequence. There it is. That's what you can think about. That's an example that you can associate with this word. Okay, going forward, do your best. Try to be critical in your thinking as to not get them confused.